Last video, I introduced you to the law of cosines. There are 3 different versions here. You choose which one works best for your situation depending on which sides and angles they give you. You use law of cosines specifically if you know all 3 sides of a triangle or if you know 2 sides and the angle between them. Last video talked about this situation. This video, we're going to do all sides. Let's start. Example 3, solve the triangle. We are going to start by labeling our sides. Across from angle A is side A. Across from angle B is side B. Across from angle C is side C. If you did not remember that side, side, side is a law of cosines problem, when you try to set up the law of sines, I know this little a is a 3. I know this little b is a 2. I know this little c is a 4. But I don't know the numbers for an entire fraction. I can't easily figure out what angle A is. I can't easily figure out what angle B is. I can't easily figure out what angle C is. So law of sines gets me stuck. That means I need to use law of cosines instead. You can solve for either angle, any of these 3 angles that you want. I like to just stick with the rule, go from smallest to biggest. So if that's the case, the smaller side is across from the smallest angle. The biggest side is across from the biggest angle. So I am going to solve for angle B first. That means I want to use this version of the law of cosines. Okay. Let's fill in everything that we know. Little b is a 2, little a is a 3, little c is a 4. I do not know what angle b is. I'm going to go on and square everything. 2 times 3 is 6, times 4 is 24. Here is where most people get stuck, lost, mess up. A lot of times they try and compare, they try and combine all 3 of these numbers here, but that is not gonna work. This 24 is times cosine B. It has the cosine B attached to it, whereas 9 and 16 are just constant whole numbers. So do not combine 9, 16, and 24. That is wrong. Instead, you can combine the 9 and the 16 if you want. But now you're going to have to solve this just as if you had this basic algebra problem, solve for x. If I gave you this problem, most of you would know I'm going to subtract the 25 and then divide by negative 24. Same exact situation here. We're going to subtract the 25 over to the other side. So that adds to 0. And now divide my negative 24 over to the other side. I'm left with just a cosine B over here on the right-hand side. I need to find angle B. Remember, whenever you're looking for an angle, that means use inverses on your calculator. So inverse cosine of the negative 21 over negative 24 gives me angle B. Make sure your calculator is in degree mode. Second cosine negative 21 divided by negative 24 gives you angle B is 28.96. Now I know an entire fraction's worth of numbers, so I can finish this problem using law of sines. I could repeat the process that I just did here to find angles A and C, just using one of these 2 versions. but I prefer to use law of sines. So if I was going to solve this problem, I would use law of sines. Remember, you should solve for the smaller side, smaller angle first. So I would cross multiply these two fractions here. Divide your 2 over and use inverses on your calculator. This is law of sines. So use inverses on your calculator and type this in. Angle A is 46.58. Now that I know 2 of my 3 angles, I can quickly subtract from 180. And see that angle C is 104.46. This is good. My biggest angle is across from my biggest side. My smallest angle is across from my smallest side. So I probably did everything correctly. Remember, we are subtracting this piece over to the other side before we divided this piece over to the other side before we did inverses to solve for our B. So when you multiply all these pieces out, you subtract these two, the A and the C, you divide this piece, and then you use inverses. Some people like to memorize this formula as is in its normal non-fractional state, or they like to write it as subtract these two pieces over, divide this piece, and then use inverse cosines. I could rewrite this middle one in terms of B. So little b squared, if I subtract my a squared and my c squared, if I divide my negative 2ac, and if I use inverse cosine here, I can rewrite this middle formula in terms of angle B. You could do the same thing for all of these. I don't have this memorized. I have to look at this format and then write it this way because I think it looks like a big mess. It's easier for me to have it written out all nice and neatly and know to solve using reverse PEMDAS. You subtract before you divide, before you, I don't know where inverses comes in PEMDAS, but solve it that way. Anyhow, let's do one last example of side, side, side. If I can find it. Solve the triangle shown below. Okay, let's start by labeling our sides. Across from angle A is little a, across from angle B is little b, and across from angle C is little c. This is a side, side, side triangle, so we're going to use law of cosines. But if you did not remember that, when you set up law of sines, I don't know the numbers for an entire fraction, and I can't easily figure out what angle A is, or angle B, or angle C in order for me to know the numbers for an entire fraction. So law of sines doesn't work. Instead, I'm going to use law of cosines. I want to solve for the smallest angle first always. It's easier to just be consistent that way. So the smallest side is 5. That's A. That means I'm going to solve for angle A first. Okay, let's fill in what we know. if you wanted to use that other format here, you could plug in your A, B, C's and type this into your calculator. I'm going to show you the long way because I think this is better for you to brush up on your algebra. Okay, 5 squared is 25, 7 squared is 49, 11.2 squared is 125.44. 2 times 7 times 11.2 . All right, to solve for angle A, I need to subtract, divide, inverse. You can add the 49 and 125.44 together if you wanted to. Let's do that. But then it's still the same idea. Subtract, divide, and use inverses on your calculator. Okay, second cosine negative 149.44 divided by negative 156.8. Make sure you're typing in your negatives and you're keeping up with your negatives, because if you mess that up, then it's going to mess up the rest of your problem. Hint here, as long as you are solving for your smallest angle across from your smallest side, this answer should always be less than 90 degrees. Most likely you're going to end up with double negatives in this fraction here. Okay, angle A is 17.62. That means we know this entire fraction here now. Solve for the smaller side out of what's left. Next, I'm going to solve for angle B then. I like to use law of sines, but you could use law of cosines again, using one of these formats to solve for B or C, or using the original law of cosines format like we just did in subtracting, dividing, and using inverses. Okay, let's use law of sines though. That's my favorite way to do it. I think it's the most straightforward way to do it. Cross multiply, divide your 5 over, and because we're looking for an angle, that means we have to use inverses on our calculator, or inverses in general. We just happen to need a calculator to do this. This is law of sine, so make sure you don't press sine. Make sure you do press sine instead of cosine. You'll get that angle B is 25.07. And now that I know that angle A was 17.62, angle B is 25.07, and angle C has to equal 180 because this is a triangle. I can subtract from 180. I'm surprised that angle C is that much bigger, but you know, that's what happened. I know angle A, B, and C. I said this earlier with law of sines, make sure you're using sines here and not cosines. I see it happen more often that people put sines here when they're doing law of cosine. So just be careful. It's an easy mistake. And then one last thing I wanted to mention, If you have word problems, a lot of times they like to, instead of just straight up telling you angle A, angle B, angle C, it likes to use this format here, angle ABC. That means angle B. So from A to B to C, A, B, C, from A to B to C, angle B.